Example 4 is a logarithmic equation, and it says to solve log of 3x minus 5 equals 2. If you're doing a logarithmic equation, it's very, very important the base needs to be there. So if it doesn't write a base, understand the base to be what it is, which is base 10. So this is log of 3x minus 5 base 10 is equal to 2. Now, two situations for logarithmic equations, and this is the only one I'm giving you right now. I'm hoping that none of the homework problems get beyond this. I'll throw one extra one at you just in case it does. All right, log equals number. All right, this is a great place to be. Log equals number, we can handle that. Okay, if it's 17 log equals number, we're not ready to go. All right, if it's even -5 log number, we don't know ready to go. But the fact is, the location of the variable establishes how we're going to do this. So the variable is inside the argument of the logarithm. I don't want the logarithm in there anymore. If that was a numerical argument and x was over here somewhere, just evaluate the logarithm, you're ready to go. All right, so again, depending on where the variable is, logarithmic equation, typically the variables are in the argument. All right, next. Once you get log equals number, once you get to that point, just change from an exponential equation. This base raised to that power equals that argument. So 3x minus 5, the argument, is equal to 10 squared, which is 100. If you can do it in your head, great. If you can't, write it down and then use a calculator. But again, that 100 is not just some magical 100 that showed up. It's this base raised to that power equals this number. And that's just changing to an exponential structure from a logarithmic structure. The log is now out of the problem. We're left with 3x minus 5 equals 100. Therefore, 3x must equal 105. Dividing both sides by 3 gets us x equals 35. Now, one stipulation on a logarithmic equation, you cannot take the log of a negative number. That's a rule, right? Yeah. We know this rule, all right? So if we can't take the log of a negative number, we need to verify, not that this actually works, but just that this number here doesn't create a negative number in the logarithm. Okay? So if I try it out, 3 times 35 is 105, minus 5 is 100, not negative. That's a good answer. We're good to go. Now, I'm not sure, because I can't remember, I didn't look at the homework, but let me throw you a couple curveballs here if they should do this. Suppose they have 3 ln of 2x minus 4 equals 12. Suppose they give you something like that. So it's not just log equals, it's 3 log equals. All right? Two choices. Choice 1, put the 3 up here. So it's a power. We'll call that the bad choice. Choice 2, divide both sides by 3. Just basic algebra. We have an equation. We divide both sides by the same number. We create an equivalent equation. 3 divided by 3 cancels, leaving me with ln of 2x minus 4. 12 divided by 3 is equal to 4. Even if it didn't divide evenly, it's still better to do that than it is to make 2x minus 4 go to the third power. You're making things more difficult than it has to be. So, divide both sides by that. Even if this was 17, 17 divided by 3 is better than 2x minus 4 to the third power. All right, so just keep that in mind. And then from that point, it works the same way. E to the 4th power equals that. You can go ahead and solve it. E to the 4th power, you can use a calculator to approximate that. All right. The other thing they might throw at you today, I'm not sure if they're going to do that or not, log base 2 of x minus 1 plus log base 2 of x plus 3 equals log base 2 of x squared minus 7. Something like that. All right. Everything's got a log. It's all base 2. It could be base 7. It doesn't matter what base it is. But they're all the same. They have to be the same. 2, 3, 4, that wouldn't be good. All right, but they're all the same. All right. If we have log equals numbers, just change to exponential form. You're ready to go. If it's log equals log, all right. First off, you want to get a single logarithmic expression on one side, a single logarithmic expression on the other side. Laws of logarithms existing here. So if I'm adding logarithms, I'm going to get log base 2 of the product of these two things, which is x squared. 3x minus 1x is going to be plus 2x, and then negative 1 times 3 is negative 3. You want to get log equals log. Then, once log equals log, argument 1 is equal to argument 2. Okay, once log equals log, argument equals argument. That means those subtract x squared from both sides, those go away. Move the 3 over here, we get 2x equals negative 4, so therefore x equals negative 2. Oops. Okay, so this represents my candidate for a correct answer. Go up here. Negative 2 minus 1 is negative 3. That's no good, right? So the empty set. Right. If you create even a single negative argument, or a zero argument for that matter, you got to throw it out. More often than not, when that happens, it's a situation where you have several answers, one works, the other one doesn't. Occasionally none of them work, and in which case you can empty set it. But again, if it's a sum or difference logs, I think for sure, I'm pretty sure that they're tomorrow's lesson that we're going to have them like that. Just in case they show up tonight, though, that's how you handle it. You get a bunch of logs added or subtracted, a bunch of logs added or subtracted. You get a single log expression using those laws of logarithms. Powers move up, addition, multiply, subtraction, divide. And then once you get log equals log, argument equals argument, solve the remaining equation. That's how to handle that.